Alrighty, let's talk about volumes of cones, pyramids, and spheres. So last time when we posted a video, we dealt with prisms and a cylinder. And we calculated the volume of these objects by finding the area of the base and multiplying it by the height. Okay. Depending on the base, that formula would change. But now when we deal with these ones, they are a little bit more complex, and we aren't going to be responsible for deriving those formulas. You are going to be given them, and you can see I have the cone as 1/3 pi r squared times h, pyramid as 1/3 length, width, height, and the sphere as 4/3 pi r cubed. So all of those formulas you are provided with, so we're going to use them in a couple of examples. So example 1 says, when sand, gravel, or grain are poured onto a flat surface, the shape of the pile will be a cone. A gravel pile in a maintenance yard has a diameter of 3.5 meters and a height of 1.2. What's the volume of the gravel in that pile to the nearest tenth? So basically what we're being asked is to find the volume of that cone. Okay, and the formula for volume of a cone is 1/3 pi r squared times h. So we can go ahead and put in all the numbers we know. 1/3 times pi. The diameter is 3.5, which means the radius is going to be half of that. So we're going to take 3.5 divided by 2, and we're going to get 1.75 meters. So my radius is 1.75 meters. We'll square that value, and we'll multiply by the height of 1.2. Now we haven't quite done an example like this yet, where the units are different. And what I mean by that is what happens if one of them are centimeters and one is in meters. In order to use those numbers in your calculation, we would have to convert them so that they were the same unit before we put them into the formula. Since here they're both meters, we're okay. And our final answer to the nearest tenth is 3.8 meters cubed. Okay, so there's the volume of gravel in that pile. Part B asks, what will the volume of the stockpile with double the dimensions be to the nearest tenth? So what we're going to do is use the same formula, pi r squared times h, and we're going to double the dimension. So let's say instead of the radius being 1.75, we double it, so we have 3.5 meters, and we'll square that value. Okay, if the height was originally 1.2, we're going to double it, and it becomes 2.4. Okay, when we end up multiplying those together, we get 30.8 meters cubed. Okay, so there is my volume to the nearest tenth. Okay, example 2. The Great Pyramid of Giza, the oldest 7 wonders in the world in Egypt, had an original height of 146.5 meters, and the base measured 230.4 meters on each side. How much stone to the nearest tenth was used in the construction if the pyramid was solid? Since it's solid, we're dealing with a volume. It's not hollow on the inside, or we'd be dealing with surface area. Okay, so we have to figure out what shape this pyramid is, and conveniently enough, it tells us it's the pyramid. Okay, and our formula for the volume is 1/3 length times width times height, and we can go ahead and put in all of those values. Okay, so the base measures 230.4 meters, the width 230.4 meters, and the height is given to us as 146.5 meters. Okay, so when we go ahead and grab our calculators, put in those numbers, to the nearest tenth, if necessary, we get 2,592,276.5 meters cubed as the volume of stone needed. Okay, example 3. A tennis ball has a diameter of 6.7 centimeters, and it is a ball. So this tells us that we have a sphere. Okay, what is the volume to the nearest tenth? Okay, so our formula for volume of a sphere is going to be 4 over 3 pi r cubed. And if we were to do all of that, we can put in our numbers. So 4 over 3 times pi. The radius, again, take the diameter, cut it in half. So 6.7 divided by 2, and we get 3.35. And we're going to cube that value. And if we grab our calculators, put all those numbers in, you get 157.5 centimeters cubed to the nearest tenth. Okay, part B, tennis balls are commonly sold in cylindrical containers in packs of 3. What's the volume of the container if it has the same diameter as the tennis ball and a height of 20.5? So we're looking for the volume of the cylinder. We have the same diameter and we have a height. So volume of our cylinder was pi r squared times h. Now if the diameter was the same as the tennis ball, that means the radius is the same. So it's going to be 3.35 centimeters squared. My height is 20.5 centimeters. So once all of those things are in place, we're going to grab our calculators, round to the nearest tenth, and we get 722.8 centimeters cubed as our final answer. So as you can see already, the volume formulas are much shorter and a lot easier to work with. Okay, so we'll end it there, and we'll do the last 2 examples, numbers 4 and 5, in another video.